Okay, everybody. Okay, good. Let's resume our meeting, and yeah, that that's a limit we have. We audio. Can you hear it?
Yeah, yep.
All right, all right. Okay, and let me mute you all so that I don't have echo here. Okay, good. So I'll be the only one speak, and you can unmute whenever you have questions. Okay. All right, so, and then we have confidence intervals for one population mean when sigma is unknown. We saw the case when sigma is known, and but when sigma is unknown, there might be some problem with the missing piece of information. Sigma is a piece of important piece of information. If we don't have that, what will happen is that we will have more variability. So to deal with that, we use a T instead of a Z to address the issue. You see a Z and T here. Z distribution and T distribution, they are very close. The differences is that when sigma is unknown, you replace it by an S, and then it follows a T. Excuse me. For Z distribution, you have mu as center, and well, you have 0 as center, and the sigma as 1 and standard deviation. But a regular normal distribution member has a mu as center, and then here in this case, sigma square over n is a variance, and then of course sigma over square root n will be the population standard deviation. We call population standard error, because this is a sampling distribution of sample mean. And then for T, we follow the T distribution with a degree of freedom n-1, which is sample size -1, give you a degree of freedom. And the degree of freedom will determine everything, all the characteristics for T. So degree of freedom is the key, is the parameter for T. So, and you can see from here that the distribution, you can see from here that the T distribution and Z distribution, they are very similar. They are very similar. You can see that Z distribution follows what? The green curve, okay, and T distribution follows the blue, okay, and the orange, the orange curve. So the differences, main differences, the green curve, the standard normal distribution has a more centralized. Okay, you see, central area is taller, higher. The peak is higher, and the tail are thinner, right? You see. But for the blue and the green, blue and the orange color one, their tails are heavier than the green one, and their central part are thinner, are smaller, peak are lower than the green one. So that means more variability. When you have heavier tail, that means the probability for extreme values is higher, is larger. Okay, therefore you the chance of is higher and larger, and therefore the probability of more extreme value to occur is also larger. Okay, now so a story about the T distribution. If you click on the link here, which I will send you these PowerPoints to you all as well. Okay. When you click on it, you will see that the T distribution was proposed by, was first used by a guy called William Gossett, who worked for Guinness Beer Company in Ireland, Dublin. If you have tried out their beer, maybe you will taste good, delicious. I don't know. I did not try, but you can try. Okay, if you are over 18. Okay. My point is, they use T distribution probably to control the oxygen level, I guess. I'm not 100% sure. So I assume that if too much oxygen in the during the brewing process, that may make the beer taste bitter or not so tasty. Okay, so they use that to control some ingredients in the brewing process to make the beer taste good. Okay, then he published that distribution because of business confidential information. He published it under the pen name called Student. So later, people call it Student T distribution or just T distribution. Okay, so that's the history of T distribution. So in the future, if you get a chance to go to Dublin, my suggestion would be that you go to the Guinness building, which is a tower. On top of it, there is a Sky Restaurant. And then that Sky Restaurant has a transparent glass through which you overlook the city and have a panoramic view of the beautiful city. I suggest that you order a cup of beer, enjoy the beer, but then thinking about tea distribution, because that's what makes the beer so tasty. Okay. Well, then that's not a joke. That's that may be a fact. All right. Okay. So very good. So and then yeah, I think yeah, okay. So and then the step you follow for constructing the confidence interval would be similar. So when you use you can still use the stat disk, okay, to calculate it. But this time you plug in what? Suppose you don't know the sigma, and then you get the sample standard deviation here. Let's say 10. Okay. Your sample mean is the same, but your sample standard deviation is 10. I pretend it to be 10. Okay. Now you plug in a different place and evaluate. Now this time it comes out with a T distribution. This interval is constructed through a T instead of Z. All right. So as you can see, and Statis does everything for you automatically. If you are to do it to Excel, and you can use what? And sorry, I mean, this is our student list. Okay, so then you can use what? You can use a confidence interval equal confidence and norm or T, depending on which one you use, norm, right? And you will return the interval for you. And you plug in alpha. Alpha is 0.05, and standard deviation, okay, 12.1, and then sample size 50. All right, and this will give you the interval width. The interval width. So in order to calculate confidence interval, you have to then divide this interval by 2. Okay. You have to divide this interval by 2, and in order to what? You have to 3.3. Oh, okay. 3.35. Actually, you don't have to, because this is a margin of error. So Excel actually calculate the margin of error for you. So then you plug this confidence that norm give you the margin of error. So you just plus minus this with the sample mean, and then you will get the upper bound and lower bound for the confidence interval. Okay. Okay, and then if this is given that 12.1 is a population standard deviation, if you don't know population standard deviation, then you will have to use the T instead of norm. You use T. And then once you use T, 1 second, sample size, 50, standard deviation alpha. Okay, once you use T, you get 3.43, 3.43, 0.1. If you plug in here, you see 3.43, the same. So statistics and Excel give you the same margin of error, and margin of error plus sample mean give you upper bound right here, and margin of error minus sample mean minus margin of error give you a lower bound. Okay, so this is a way to construct the confidence interval, and the way to make some prediction. I mean, estimate of the population parameter of interest to you. Again, use that use that example in the large sample, in the example of estimating the average monthly saving amount for typical French family. That you can estimate it this way. Okay, draw a sample which is representative of the population through random sampling, okay. And then construct. You can get a sample mean and sample standard deviation. Then you use the T distribution, because most of the time you don't know the population standard deviation. Okay, and you can use statistics or you can use Excel. All right, and you can construct an interval easily to that purpose. All right, but then when you use a T distribution, you need to bear in mind that T distribution has the underlying assumption, which is the population distribution need to be normally distributed. And the way to to verify that is through what? The way to verify that is through QQ plot or normality plot. So construct a normality plot, which you can do in Excel. Okay, that when you use Excel, it should be able to show you the normality plot. Okay, data analysis, normality plot. If you click on the descriptive statistic, there should be normality plot. Otherwise, you have R, okay, and then also later, I was have you download real statistic for your third project, okay. So later you will see that for the third project you can download the real statistic as an Excel's add-in in which you will definitely have the QQ plot, normality plot. Okay, so very good. So I think this is the this is good for the interval estimation. All right. Any questions so far? Let me see the audience. Very good. We have 7 students in here, and others can listen to the recording. This is not bad. Okay, let's see. Waiting. Any question? Okay. Waiting. Do you have any question? Okay. Very good. Okay, but you can hear and see clearly, right? Okay, very good. Not bad. Okay, and let's see who is this. Jennifer. Rajhav. Okay, all good. Okay. Shen, Wei Shen. Okay, all good.
Yes.
Okay, all right, very good. Young patient. Oh, good.
Yeah.
Okay. All right. Very good. I like it. Okay. This is well, this is a new way to do it, but I think we are doing well. Okay. So give me. I will keep screen going on like this, and I will come back. Okay. Stay here. I'll come back in 3. Let's have a 5 short break, just 5 minutes, and then we'll continue with the uh, we'll continue. Actually, I will. I may go ahead to the regression part, and then because that's more important. That's most important. That's when your project will be. So I will cover that part first. Then I will. Then after that, probably we run out of time for the morning. So I will finish the recording of the third part, which is hypothesis testing later. But that part won't be you won't need that part for your project 3. So we'll cover the important part first. So hang in there here for 5 minutes. Okay, you can do anything you need. I'll come back in 5 minutes after I use the restroom. Okay, all right. See you. Let me. I will end the recording here. I'll end the recording. Stop recording.